I'm trying not to cry. It's just math is so dear to me. Okay, here we go, guys. All right. So we're now to example number 2 in section 3.4, and we're trying to solve for x here using our natural logs and using our logs right here, right? So no one probably could do this in their head right now, saying e to what kind of numerical value that's going to give you 72. So we're going to have to use our inverse property or something like that to get rid of e. So let's think about one of our logs or natural logs that has a base e. Natural log, right? So since natural log has a base e, I would take the natural log of both sides. And the reason we do that is because natural log has e as its base. And that's how we can get rid of these. Okay, so if you're wondering, well, how do you know what to do? The purpose and the reason is to get rid of this value so we can get x all by itself. And so that's why it's imperative that you know our 3 properties that you learn for natural logs and then 3 properties for logs. So those are gone. So x equals the natural log of 72. That's what I do right here. Now come over here now. Same thing, we want to go ahead and solve for x here. So we have 3 times the quantity to the power of x is equal to 4. So since this is a multiple, let's just go ahead and divide both sides by 3. Okay, so I'm going to go ahead and divide both sides by 3 here. Alright, to the power of x equals 4 to the power of 3. Okay, so our goal now again is to get x all by itself. And let's think here. Our natural log doesn't have a base 2, alright. And our log by itself doesn't have a base 2, but can't we change the base of any log, right? You can make it base 1, base 2, base 3. You can change it to any base you want. So let's take the log of both sides and check out what happens here, okay? If I take the log of 2 to the power of x equals the log of 4/3, okay? Check this out. We have this really neat property here, okay? And the property says if you ever take the log of some value and you're raising whatever you're taking the log of as an exponent, you can bring this exponent down so now it's a coefficient. Pretty neat here because then we're going to be able to solve for x. So check this out. Alright, so my next property or my next line is going to be x log 2 equals log of 4/3. And what's my base right here? 10, right? And our calculator can do log base 10, which is really neat. That's why it's a really cool property here. We can divide both sides by log of 2. This would be our precise answer, but if you actually want to get a decimal version of this, approximately, you would put log 4/3 in your calculator, divided by log 2, and it's going to give you something like 0.38 or something like that though. But it's really neat if you're given something that we don't know the base of, just take the log of both sides, which we did right there, and they're going to be able to solve and get x all by itself.